It is also very important to notice that there are actually different types of atoms. We have some of the atoms that are charged atoms, some are neutral. So let's say we have an atom that has a charge of plus, a plus charge, and then one that has a minus charge. This one is a charged atom, so we can't say it is neutral. Most neutral atoms, all the neutral atoms actually don't have charges. So, and the number of protons in the nucleus of the number of protons in the nucleus of an atom and the number of electrons in the shells always cancel out to make the atom neutral. So you could be asked to explain why the atom is electrically neutral. An atom is said to be an electrical neutral particle because the number of protons is always equal to the number of electrons. So if I have 3 protons in the nucleus, 3 electrons, we say the atom is neutral because they cancel out. And in a neutral atom, please listen to this one, in a neutral atom, the number of protons is always equal to the number of electrons. This one will lead us to what we call the atomic numbers and then the mass numbers. So in a neutral atom, the number of protons is equal to the number of electrons because it has not gotten any charge on the atom. So now let's look at what atomic numbers and mass numbers are. Atomic number, you realize that in our previous lesson when we learned about the elements, and then I think the first 20 elements and then some of the other ones, we realized that the first 20 elements, each atom has got a number. Each atom has got the number. Just as hydrogen is 1, helium is 2, potassium is 19, calcium is 20, aluminium is 13. So these numbers are their atomic numbers. So atomic number is the number of protons in an atom, or the number of protons in the nucleus of an atom. So atomic number is the number of protons in the nucleus of an atom. And once the atom is neutral, so atomic number is the number of protons in the nucleus of an atom. And once the atom is neutral, that it hasn't got any charge on it, it means that the number of protons is always equal to the number of electrons. So we can have atomic number to be equal to the number of protons and to the same time equal to the number of electrons. So that is when the atom is neutral. When it has not got no charge, we said the atomic number is the number of protons in the nucleus of an atom. And the atomic number in a neutral atom are charged in it. So an atom without a plus, without a minus, the number of protons is always equal to the number of electrons. We will use this. And scientists denoted the number of protons or the atomic number by the letter Z or Z. So take note of this. Then we will move to look at the number, the mass number. And the mass number is the sum of the proton numbers and the neutron numbers in the atom. So mass number is the sum of the proton number and the neutron number in the nucleus of an atom. So that is the proton number plus the neutron number. And scientists denote the mass number by the letter A. So A is equal to the proton number plus the neutron number. We have a new equation now. That mass number is the sum of the number of protons and then the neutrons in the nucleus of the atom. So P plus N. And then you remember we said that the number of protons is the same as the atomic number, and the atomic number is denoted by the letter Z. So we can have our new equation as A is equal to Z plus N. So here our mass number is equal to the atomic number, which is the same as the proton number, which is the same as the number of electrons in the neutral atom, plus the number of neutrons. Now let's see how we represent an atom with the atomic number and then the mass number. So let's say we have an atom as X, an element as X. This is the element. Now the atomic number, our Z or Z, is always a subscript. It's represented as a subscript, and then the mass number, the A, is represented as a superscript at the left side of the element. So if X is our element, we said that the atomic number is represented as a subscript. So here is our atomic number. Then the mass number is represented as a superscript on the left side of the element. So this is it. So this is how we represent an atom using the mass number and then the atomic number. So atomic number down, mass number up. Atomic number down, mass number up. Don't forget that our atomic number is denoted by the letter Z or Z, and the mass number by the letter A. So let's take an example. Let's say an element X. So let's use sodium. Sodium is the 11th element. When you count the first 20 elements, sodium is the 11th element. And because it is the 11th element, it has 11 protons. And 11 protons means that the atomic number of sodium is 11. And the mass number, most of the time, it will be given to you, so you don't need to really put it in memory. But there's actually a shortcut to do that. There are other exceptions, but if the atomic number is odd, you multiply it by 2, then you add 1. If the atomic number is odd, you multiply it by 2, then you add 1. So this one is odd. You multiply it by 2, you get 22. Then you add 1, that is 23. So this is the mass number, and this is the atomic number. Now, with the help of the mass number and atomic number, you can make a whole lot of predictions. You can do a whole lot of calculations with it. You can actually find the number of neutrons in this atom. You can actually find the number of neutrons in sodium atom, because we know that the mass number is equal to the sum of the proton number or the atomic number plus the neutron number. So simply we just go and then subtract the down one, that's the atomic number, from the top one. So if the top one is 23, we subtract it from our 11, that's our n. So our n is 12. So the number of neutrons in sodium is 12. So once you draw the make atomic structure for sodium, you realize that you are going to have 11 protons and 12 neutrons, and then the shells follow. I believe it's getting clearer and clearer. So without much ado, let us take another example and then see, still on the atomic number and then the mass number. Let's take aluminium. aluminium as the X. Aluminium, for example, we can also look at aluminium Al, and aluminium is the 13th element. So the atomic number of aluminium is 13. So we have our 13 here. And I said the mass number, you can get it this way. Sometimes it could be given to you, but to get it easily, when the atomic number is odd, you multiply by 2. But when you add 1. So you multiply by 2, then you add 1. But when the atomic number is even, you just multiply by 2, and that is the mass number. So here, atomic number is odd. Multiply by 2, that is 26 plus 1, 27. So this is the atomic number and then the mass number. So this one is for aluminium. You can actually calculate for the number of neutrons in aluminium by just subtracting the atomic number from the mass number. We can also have examples like oxygen. Oxygen is the 8th element. So 8 here and 8 elements. So this 8th element, the 8th is the atomic number. And like I said, because this is even, if you multiply this by 2, it should give you the mass number. And this is 2 times 8 is 16. So the mass number of oxygen is 16.